Let's see what prediction we get. Remember that this employee said that its previous salary was 160K. And now let's see what says a random forest composed of 10 trees. So let's execute that. And it says that the previous salary was $141,000. So that's actually a very dangerous prediction because we're way below the 160K salary that this new employee said to have in its previous company. So if we trust this prediction, we would actually think this employee is bluffing. But no worries, we will not stop here. Right now we're going to try a random forest with a lot more than 10 trees. So let's pick, for example, 100 trees and let's see what we'll get. So I'm going to rebuild the model. Here we go. And now let's look at the graphic results. And as I was telling you, we don't get much more steps in this plot of our new random forest regression. You know, we multiplied our number of trees by 10, but the number of steps was definitely not multiplied by 10. If we can compare that very quickly. This is the previous plot, and this is the new one. 10 trees, 100 trees. We can see that we have maybe a little more steps, but definitely not 10 times the previous steps. So the reason for this, the explanation, is related to this convergence idea that I talked to you about. And so what changes here with 100 trees in terms of the plot is not the number of steps that was increased, but a better choice, a better location of the steps in the stairs with respect to our salary axis. That means that maybe the steps are better located to make our ultimate predictions of the salaries of each of our level from 1 to 10 incremented by 0.1. So to check that out, we simply need to make our final prediction to predict the salary of the 6.5 level. So let's recap. The employee is saying 160K. Our random forest with 10 trees said 141K. And now let's see what say our random forest with 100 trees. Execute. And now it says 166K. So much better. We're getting close to the supposed real salary of 160K. And besides, we're now actually on the good side of the negotiation because we would no longer think that this employee is bluffing. So since the prediction seems to be improving as we increase the number of trees, let's actually try with 500 trees. So that's a huge forest we have now. So let's execute this to build our new huge forest of 500 trees. Here we go. New forest created. Let's have a quick look at the visualization plot results, but it's going to be the same thing. We will not get a lot of more stairs, maybe a little more. Well, actually, let's check it out. Well, definitely not. We seem to have the same number of steps in the stairs, but as I was telling you, each of the steps in the stairs might actually be better located to make each ultimate prediction of the salaries for each of the 10 levels here. So the best way to check that out is actually to get our ultimate prediction of the salary of the 6.5 level. And let's check it out. Let's see if we get a better prediction than 166K. Executing, and right in the spot. We hit the bullseye with 160,458 predicted salary. So awesome job that this random forest with 500 trees just did here, because it predicted almost the same salary as the supposed 160K salary that this future employee said to have in its previous company. And actually, so far, before we made this random forest with 500 trees, the best model that made the closest prediction to this 160K salary was the polynomial regression model. And now the random forest regression is beating the polynomial regression model because now we get a prediction that is almost the same as a real value. So right in the spot, congratulations, we actually made our final model. And now I just want to conclude this tutorial by making this transition to one of our future parts, which is actually part 10. In part 10, we will build some ensemble machine learning models. That is, some models that are a combination of several machine learning models. And you know, in machine learning, these are actually the best models. You know, when you have a team of several machine learning models, they can actually make an awesome prediction, because unless we have an Einstein machine learning model in our combination of machine learning models that is the only model to be right, well, you're more likely to get the correct prediction with 10 machine learning models predicting the same thing than with just one model. So that's actually what we did here. Well, we had a team of same machine learning models, which were decision tree regression models, but in the future we'll make a team of different machine learning models. So that's going to be very fun. That's going to be very powerful as well. And I look forward to getting there with you. So now I'm telling you congratulations for two things. First, for building this very powerful regression model, the random forest regression model. And second, for having built all are regression models. We build some linear regression models, some nonlinear regression models, some nonlinear non-continuous regression models, and some nonlinear non-continuous ensemble regression model. So congratulations, you're definitely on your way to becoming some expert in machine learning, but wait for what's coming next. So speaking of what's coming next, I look forward to seeing you in the next sections or next parts. And until then, enjoy machine learning.